In this video, I'll explain the concept of Jacobians. Suppose you have two functions u and v. These two are functions of x and y, that is u equal to u of x comma y and v equal to v of x comma y, where x comma y are two independent variables. Then Jacobian of these two functions with respect to independent variables x and y is denoted as j of u comma v with respect to x comma y, or else we can denote the same thing as dou of u comma v by dou of x comma y, which is equal to determinant of the first row is dou u by dou x and the second element of first row is dou u by dou y. Then second row dou v by dou x and dou v by dou y. The meaning of this is determinant of partial derivative of u with respect to x, partial derivative of u with respect to y. Second row, partial derivative of v with respect to x, partial derivative of v with respect to y. Thing as determinant ux y and vx vy. Suppose if you have three functions u, v, w of three variables x, y, z, then Jacobian of u, v, w with respect to x, y, z is defined as determinant of ux, uy, uz, vx, vy, vz and wx, wy, wz. That is partial derivative with respect to x, y, z respectively. This is the definition of Jacobian of any given function. When two functions are given, it is 2 by 2 determinant. When three functions are given, it is 3 by 3 determinant. Now, let us learn some properties of Jacobians. If you have u and v, these are functions of r and s, then R and S are functions of x and y, then they are functions of x and y. Then in that case, Jacobian of u comma v with respect to x comma y is given by dou u comma v with respect to r comma s first into dou of r comma s with respect to x comma y. It is like a chain rule for finding the Jacobian, where u is a function of u and v. These are functions of r and s. R and s are functions of x and y. Then Jacobian of uv with respect to x and y is Jacobian of uv with respect to rs into Jacobian of rs with respect to xy. One more property is if J is the Jacobian of x, u and v with respect to x and y, and J dash is the Jacobian of x and y with respect to u and v, then J dash is always equal to 1. This value you should remember. And one more thing is if u and v, these are not independent functions, these are not independent, in that case Jacobian is always equal to 0. So if you get Jacobian of any two functions equal to 0, then those two functions are not independent. There are few properties of Jacobians. Now let us solve few problems. See the first question. This is a simple question. U and v, these are two functions in x and y. You have to find the Jacobian of u and v with respect to x and y. So, dou of u comma v with respect to x comma y equal to the determinant ux, uy, vx, vy. So, this is equal to ux means partial derivative of u with respect to x. You have to treat y as constant. Derivative of x square is 2x. As y is a constant, derivative of 2 minus 2y is 0. Then partial derivative of u with respect to y. Now you have to treat x as constant. So this is first term 0 minus 2 into derivative of y is 1. So it is minus 2. Vx, partial derivative of v with respect to x, it is 1. because derivative of x with respect to x is 1 and y is a constant. Then vy, partial derivative of a v with respect to y, derivative of x is 0, derivative of y with respect to y is 1. Now you have to evaluate this determinant. That gives you, this is the way of evaluating 2 by 2 determinant, this cross multiplication method, 2x plus 2. Therefore, Jacobian of these two functions with respect to the two independent variables x and y is 2x plus 2. See the second problem, if u, v, z, these are the three functions given in three independent variables x, y, z. You have to find Jacobian of u, v, w with respect to x, y, z at this particular point. Therefore, the formula for Jacobian of three functions with respect to the three independent variables is determinant ux, uy, uz, vx, vy, vz, wx, wy, wz. So that gives you, let us find out the partial derivatives of these three functions with respect to x, y, z one by one. So partial derivative of u with respect to x, y and z constant. So these two terms will vanish. Derivative of x with respect to x is 1. U, y, these two terms will go. So 3 to the 6 y. Then u, z minus 3z square. Then Vx with respect to x, yz constant. So 4yz constant. Derivative of x square is 2x. So 4 to the 8xyz. Then Vy with respect to y, x and z constant, 4x square z, derivative of y with respect to y is 1. Then similarly, 4x square y, derivative of z with respect to z is 1. Then for wx with respect to x, y, z constant, so you will get minus y. With respect to y, z, x constant, so this 0, this is minus x, derivative of y with respect to y is 1. Wz, so this term becomes 0 here, 2 2s are 4z. So now you want at the point 1 minus 1 0. So substitute at x equal to 1, y equal to minus 1, z equal to 0. So this determinant becomes 1 minus 6 and z is 0. Therefore z is 0 means the full term becomes 0, 0. And here it is minus 4 because x square, 1 square and minus 1. Here it is minus of minus plus 1. Then here it is minus 1, then in this case it is 0. Evaluate this determinant. So you will get along first row, first column you delete it. So 1 into minus 4, then plus 6 because minus of minus plus 6. First row, second column, it is plus 4 and third row anyway it is 0. So this gives you minus 4 plus, so the value equal to 20. See the third problem, if x equal to u into 1 minus v and y equal to uv, then verify that j dash equal to 1. J means Jacobian of a given two functions with respect to the two independent variables. J dash means the reverse case. So j equal to dou of x comma y with respect to u comma v, and j dash is equal to dou of u comma v with respect to x comma y. So here x and y in terms of u and v directly given. So here find the Jacobian, that is xu xv now, because functions are in terms of x and y. Functions are x and y and independent variables are u and v. Therefore, next yu y v. So that gives you xu, partial derivative of x with respect to u. So that is nothing but the first derivative of u with respect to u is 1 minus uv, you will get derivative of u with respect to u is 1, v is a constant. Then similarly xv, here you will get u minus uv. Xv means partial derivative of x with respect to v. U is a constant, so it is 0 minus u. Derivative of v with respect to v is 1. Then similarly yu, that is v into derivative of u with respect to u is 1. Here u into derivative of v with respect to v is 1. So which gives you u into 1 minus v plus uv. So that is equal to u minus uv plus uv cancels, that is equal to u. Now, similarly here, to find j dash, you need ux, uy and vx, vy. We need the function u and v in terms of x and y. So, you have here x equal to u minus uv and y equal to uv. So, what I'll do is, to get u and v in terms of x and y, you add these two equations. X plus y equal to u minus uv plus uv cancels u. So u equal to x plus y I got. So v equal to y by u. So from this equation y by u. So y by, substitute u is nothing but x plus y. So I got u and v in terms of x and y. Now you have to substitute that in this determinant by finding the partial derivatives. So I will write this value here, that is j equal to, finally we got it as u. Now j dash I have to find out. J dash equal to ux, partial derivative of u with respect to x is 1, partial derivative of u with respect to y is 1, ux uy, done. Then similarly vx vy, partial derivative of v with respect to x. So y is a constant. Then derivative of 1 by x plus y is, derivative of 1 by x is minus 1 by x square. So similarly here, minus 1 by x plus y whole square. Then derivative of v with respect to y. Now for that you can apply the quotient rule. So denominator x plus y into derivative of numerator is 1 minus numerator into derivative of denominator, x is a constant anyway. So it is 1 divided by square of the denominator, that is x plus y whole square. So minus y plus y cancels, you will get x by x plus y whole square. So now evaluate this determinant. J dash is equal to x by x plus y whole square minus of minus plus y by x plus y whole square. So which is equal to, let us simplify, x plus y whole square in the denominator, x plus y in the numerator cancels, you will get 1 by x plus y. So this is equal to 1 by, I'll write in terms of uv. So x plus y is nothing but u. So j dash is equal to 1 by u. Hence j into j dash is equal to, j is u, j dash is 1 by u, so which is equal to 1. Hence we have verified j into j dash is equal to 1. See the last problem. Prove that the functions x equal to u square minus v square, y equal to v square minus w square, z equal to w square minus u square, these are functionally dependent. When three functions are functionally dependent, if Jacobian of these three functions, here the functions are x, y, z, with respect to the independent variables u, v, w equal to 0, then we can say that those three functions are functionally dependent. So we have to find the Jacobian of these three functions. So let us find out the Jacobian. Jacobian equal to, using the formula xu, xv, xw, then yu, yv, yw, determinant zu, zv, zw. Let us find out the partial derivatives one by one. That is equal to, so with respect to u, 2u, then with respect to v, minus 2v, with respect to w, there is no w, therefore 0, because these two are constants. Then with respect to u, there is no u term, 0. With respect to v, 2v, with respect to w, minus 2w. Similarly, for z with respect to u, that is minus 2u, zv with respect to v, there is no v term. Therefore, these two are treated as constants. Derivative of constant is 0. Zw means 2w. W square derivative is 2w. U square derivative anyway 0. So now evaluate this determinant. 2u into 2 to the 4vw, then minus 0, plus 2v into, delete first row second column, 0, and this is a minus 2 to the 4uw, and third entry anyway it is 0. So this gives you 8uvw minus 8uvw, so which is equal to 0. Hence I got Jacobian of these three functions with respect to the independent variables uvw equal to 0. Hence these Three functions are functionally dependent. They are not independent, that means they are functionally dependent. I hope you understood the concept of Jacobian. Thank you for watching.